Okay, so in the last video I have explained you the position vector and the infinitesimal displacement vector. Now let's come to the separation vector. So this separation vector is very useful in electrostatic, magnetostatic, or probably the entire electrodynamics. So it is represented by this R, and this R and this R are different things. This R represent the position vector, while this R represent the separation vector. Okay. So what is the separation vector? Well, the name it suggests that that this vector describe the separation of the 2 points. So let's again draw the coordinate system x, y and z. So we have one point over here. It can be a charge if we will discuss the electrostatic, and this is the another point. Okay, so this is a charge and this is the some point in space. So separation vector, okay, so let me write like this. So the position vector of this first point, which is let's say P, is this R. Okay, this okay, let me right click. So the position vector of this is, let's say, R dash, and this another point in space, let's say this is Q. The position vector is R vector. Okay, so the separation vector is this vector. Okay, so if this P point is a charge particle and this is the Q point, maybe a point where we are trying to figure out the electric field. So this separation vector actually tells the distance between these 2 points, how this this charge, which is source, is separated from the point where we are testing the electric field of that charge particle. Okay, so this R vector is nothing from the triangle rule. Is this separation vector R is actually okay. So from triangle rule we know that this R plus, okay, so let me write this R plus this R vector is going to that R. So it is going to be this R minus R prime. So this is the separation vector. So the unit vector in that direction is this R cap, which is the R vector divided by magnitude of R, which is written as this R minus R prime divided by the magnitude of R minus R prime. Okay, so if we assume that the P has a coordinate x prime, y prime and z prime, and Q has a coordinate x, y and z, then in the component form we can write this separation vector as x minus x prime x cap plus y minus y prime y cap and z minus z prime z cap. Okay, and magnitude can be written also written. Okay, so okay, so let me remind you once that this magnitude can be obtained from taking the dot product of the same vector. Okay, so we can just do R dot R, which will gives the square of the summation of the each of the component. Okay, so we can figure out the magnitude of any vector by taking the dot product by itself. Okay, which is this. Okay, and this unit vector can be obtained from okay, it can be obtained from this this. Okay, so I'm writing just one maybe two component. Similarly, the z part divided by this term, x minus x prime square plus the other term will be there. Okay. Okay, so this is it. Now from the next video I am going to start the other part of this vector analysis, which is the differential calculus. Okay, so we will deal with the topics like okay, so let me write like the gradient in the next and upcoming video, divergence, curl, we'll also see the del operator. What is this del operator actually says? And before starting of this before starting this I will also give you a brief intro about the partial derivative, a little bit about the multivariable calculus. Okay, apart from that I will also introduce the product rules. Okay, and the Laplacian, like del square. What is del square? Okay, so this is what I'm going to do in the next video, and after this I am going to start the integral calculus. Okay,